Hello, sir. So we'll wait a couple of minutes for others to join.
Sure, sir, sure. Not an issue, sir.
Yeah. In the meantime, would you like to discuss anything related to, whole course?
Yeah, sir. One question, sir.
Yeah.
In the first session, we have discussed about the definition of the project.
Yeah.
So, in that, uh, my question was at that time, sir,
Okay.
that unique location, uh, like I was working in a power plant.
Yes.
My question was the same power plant is being constructed at two places with same specification, with same start date
Yeah.
and end date
Yes.
and the time period and the so how both the projects are different. So
Uh,
the point came like the location is different. It is unique in its location.
yeah. See, once you make any,
Hello.
yeah.
Okay, then.
Yes. So once
So
you,
today I
okay.
was revising since the starting, sir.
Yes.
So I was hearing the video in which ma'am was telling example of a stapler making company, stapler prince or stapler, I think so. To
Okay.
which I think she has not called it a project.
Yeah. Making a stapler won't be a project. Uh,
Yeah, making a stapler is not a project, but yeah, setting up the uh, infrastructure for making of a stapler is a project.
yeah. But
So
yes, sir. Please go on.
uh, video at bit of time it was there, so I don't remember. So that was a query which I wanted to uh, ask regarding that.
Uh,
So like a project is a unique in its own self
yes.
with a specific with a specific objective and with a start date and end date.
Okay. So
So
I mean, it seems like you are answering your
how
own
we can
question.
so just a question arises in the mind.
Yeah.
Also, one more thing, sir.
Yes.
Uh, if I can get the contact number of the pardon,
Uh, Sorry, I couldn't hear you.
pardon, sir, please can you repeat?
Uh, I think there is some lag between us.
Hello. So saying something that I'm answering my question. I was not able to understand
No,
what is.
see, it sounded like you are answering your own question. When we
Hello.
talk, uh,
Sir, I will be back in 5 minutes, sir.
yeah, okay, sure, sir.
Hello.
Yes, sir.
Yes, sir. Voice
So,
was not audible.
yeah,
So this is coming back from my phone.
am I audible now?
Oh, you are saying something, sir? Yes, sir. Yes. Yes, sir.
Uh, yeah, sir. So, as you
Sir,
talked
you are saying
about,
something, sir.
yeah, about stapler making, I mean, when you are repeatedly making the same thing again and again in the factory setup with no change at all, I mean, with minimal change, it's not a project. But in your case, when you talk about setting up two thermal plants, same similar, but their location might change. The people who are
But
working on it.
but that also has a different location. Two sector making companies a different location.
Uh, Sir, the project ma'am talked about was not of a stapler making company. I mean, if the company is making two staplers, you won't call it a two different project, right? It's not about setting up the company, it's about the company is set up. Now you are making staplers.
Yes, sir. Yes, sir. I
Uh,
want to tell them two different projects of making the stapler.
yeah,
Because one view might came in my mind, sir.
yes,
Today afternoon only, I gone in little bit of depth. Whenever the whenever the government budgets come,
yes,
like this much amount the government will invest in this sector, this much amount will be invested in this sector, this much amount in this sector. It is what is a nutshell. Uh, you can say that one is not coming in the mind. So for that, for investing or circulating that money in the market, there are different uh, departments and financial institutions.
yes,
Okay, sir.
yeah,
Am I right?
yes, definitely.
So in that financial institution, one of the financial is one of the financial institution is our bank also.
Yeah,
Bank is also like a financial institution.
yes.
So if bank working of a bank is a project or not?
Okay, so we considered four things in definition of project. Can you remind me again? I mean,
So
yeah,
with a specific objective,
yes,
specific objective, uh, start date and end date,
yeah,
and specifications and the uniqueness.
and some business value creation, right? But what about the start date and end date for working of a bank? When you're talking it, when you're taking it as a
The
whole,
date is enough, sir. Like yes, sir.
yeah, when you take it as a whole, it's just a repetitive process, right? I mean, uh, it's like if you automate it, it would just be a machine, right? I mean, some people coming in, going out, operating the, doing the same operations, right? So it kind of negates the uniqueness component.
No, occasions are same, sir. But uh, but circulating that budget,
Yeah,
circulating that budget in the market is also a project na, in which bank is helping us.
uh,
Circulation
circulating.
of the budget in the market is also done with the help of banks. So it is also a project for the government
Yeah, see,
to circulate the money.
running of a bank won't be a project, but yeah, specifically if you talk about that, okay,
Because the economy has to be done. It is
yeah,
also a project. How the economy will run, how the
see, does this have some specific end date? I mean, are we satisfied that after some time when everybody, uh, whosoever needed the budget, it has been circulated to that person? So if that
sir,
can be
any
done,
budget is coming,
yeah,
any sir, any budget is coming, it
yeah,
is for the fixed time. That in this much of time we have to complete or discuss this much of amount. It is also target business. Sir.
no,
Date may be extended.
yeah,
That is other thing, sir.
yeah.
But the when we are planning, the date is there.
See, if
Date may
you're,
be extended according to the works and other things, sir. Like in a project, in construction project, dates are extended
yeah,
according to the lack of manpower or
uh, see, if you're just talking about that, okay, this, let's suppose 1 lakh crore
some
was,
calamity or COVID or whatsoever may be the reason.
yeah,
So the date may be extended, not the issue.
yeah,
But the point is, here is the date. The government is planning in this much of time, this much amount should be dispersed.
yeah. So yeah, that too is a project. I mean, no, I won't consider the whole working. I mean, working of the bank as a whole as a
Yes,
project,
sir. Yes, sir. Please,
but
sir.
specifically one
Hello.
disbursement for a specific purpose done in a specific amount of time, and it is generating some business value. So I will consider it as a project.
So in that way,
Yeah.
sir, manufacturing of the stapler can also be a project.
When you link,
It can be, no, sir.
uh, see, when you are just talking about the manufacturing operation, just two
Hello.
staplers. Yeah. Is there some lag in my voice? I mean, are you able to listen, hear me clearly?
Now it's okay, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir. Now it's okay, sir.
Yeah. So, when you are just talking about making two staplers, you are not adding anything else to it. Like, let's suppose that for one specific project, or let's suppose there is one specific order, okay, that you have to deliver
Oh,
1000 staplers to one place. So, for that order, you
okay,
have
sir.
got each and everything. Like, you have got specific purpose, you have got, okay, the delivery date. So from that you have got, okay, manufacturing has to start, you have to bring the materials. So when you think of it as a whole, it will be a project. But if you just talk of going into the factory and manufacturing one by one staplers again and again, it won't be a project.
There was some voice lag, I think so, sir.
Yeah. uh, Swami sir, are you also facing the same issue? I mean, is there some voice lag?
No, no, it
No,
was from my side, sir.
yeah,
Now
we are
it's
okay
okay.
with the voice, no problem. Yeah.
Okay, sir. Sir, you can go on and define anything as a project if you add the characteristics to it. But if you're just talking, like going into a very small level and what can I say, just repetitive mechanical jobs, if you're talking about, you won't be calling it a project.
Okay, sir. But in
Yeah,
my view,
so,
it's still little bit of contradictory.
okay. So we will come to this point definitely
Sure,
again.
sir.
I mean, let's try to finish
Yeah, sir.
this
Yeah,
week's
sure.
content.
Sure, sir. Sure.
Okay, let me start presenting.
Okay, sir.
Just a moment, please. Okay, so can you guys see my screen now?
Yeah, yes. Yeah.
Okay, so welcome again. Good evening, everyone. I am Venugopal Mahajan. This is live session for the week 4 of course Scheduling Techniques in Project. The course instructor is Professor J. Maheswari. So the contents covered in this week were simulation in DSM, Beeline diagrammic methods, and some other techniques such as PERT, GURT, GPM. So we saw some content on DSM in last week. We went till partitioning, tiering, and also on active blocks, matrix multiplication too. So we'll follow the same sequence for this one big question. I mean, we'll try to cover each and everything. This the course is about scheduling techniques, and till now we haven't scheduled anything in metrics, right? DSM. So we'll try to do this. So as you can see, this is a matrix with this is a DSM already formed with I guess 9 activities. 4, 5, 6, 7, 8, 9. Yeah. So we have got some values written in the diagonal block. What is this?
That is the duration of the activity, right? That.
Yeah. In this case, we are talking about the duration of the activities. So to calculate the sorry, the project duration, uh, the steps we have to follow it. We have to partition this, and after partitioning, obviously we have to identify the cycles. Then let's see if any tiering is possible, and then for complete duration we will also need to determine the cycle duration, and that is the main part for this week. So let's do the partitioning first. The logic we use is empty rows to the top and empty columns at the bottom, right? So let's do that. Empty row, we have got y. Anything else? Empty row now. Okay, after y, yeah, r is again an empty row.
We. Yeah.
Yeah. So we have got r. Then empty columns.
U is empty.
Okay, u is empty,
Shift
and
it to the right.
s is also empty, right?
Yes, is also empty. Yeah, correct. So we
Okay,
can shift.
so you have got u and s too. What should be the order?
Can we not take any order? Does it matter?
Yeah, we can take any order, but let's see if it changes our answer.
Okay.
Yeah, u and s. What about the rest? I don't think any other empty row or column, right?
No, nothing. So
Nothing.
we'll have to see what's the cycle there and start tearing them.
Okay, so let's start writing TV WXZ. I hope everyone is comfortable with this step, right? We have done it multiple times.
Yes, yeah, we can go fast.
Uh, okay. So after this, we get this matrix. I mean, this was the order we discussed. YRTVWXZUS. It's the same here, right? YRTVWXYXZUS. And this is our active block. So what to do with it?
We will see where any cycle is there, right? Within that.
Yeah, and how to do that? I
Either
mean,
we
we
can multiply using a matrix method, or we can draw it visually and see, because we are only talking about 4 or 5 activities.
yeah, 4 and 5 activities we can
We can
see.
even visually see actually. Yeah.
Yeah. So let's first try it with the matrix method. I hope.
Uh-huh. Sure.
Yeah. So let me bring Excel for this.
Yeah, let's do. Yeah, yeah, that's easier.
Yeah. Moment of window, Excel. Okay. So can you guys see Excel?
Yes, yes, yes.
Okay. So we will try to move at a faster pace now. This is the matrix we have. Now converting into a binary matrix. Just replacing x with 1 and rest of the numbers with 0.
Yeah.
Okay, so the next step would be to square the matrix and check, right? So n square. Let's do it. So it's quite simple in Excel. Yeah, so we have got this matrix. Uh, can anybody help me determine? I mean, what's the interference inference from this?
Wherever, let's look at wherever non-zero value in the diagonal.
Okay, yeah. So non-zero value in the diagonal, we have got t and v.
So let's start with anything and see where there is a cycle. Okay.
Okay, so we'll be starting with t, right?
Yeah.
So in this case, you can see that it's quite straightforward. I mean,
It's T and V and T. There is no other confusion.
yeah, no confusion here, right?
Yeah.
So uh, let's make it a block and see where it takes us. So we'll be combining these t and v and wxz,
Yeah.
same. Uh, yeah, so how to plot it?
So let's start now. T to V is 1. So TV to TV is
Okay.
value.
See, we are not concerned about TV right now.
Yeah, exactly. Yeah.
I mean, what is happening inside is we already took care of it. We made
Yeah.
it a
Sorry.
block,
Yeah. Yeah.
right?
Yeah.
So
From W it goes to X. Okay. Let's mark 1.
yeah, so W it goes to X.
And then
Let's
from X to Z 1.
uh, okay, X to Z is one, and
Z
yeah.
to W. Okay.
So so this is our matrix now. Again, we can see that now this
But
become,
actually,
yeah,
instead of multiplying, sir, we can actually see there is another loop, W to X, X to Z, and Z to W, right?
yeah,
So then,
yeah. We can
Sir,
exactly,
for sir, sir,
yes,
before seeing the loop, we have to do for the partitioning for the same block now, no?
yeah,
For the empty rows and empty columns.
yes, definitely. So what will happen right now is that now this becomes your matrix under consideration. So you look for it. I mean, empty rows, empty columns. In this case, you find that you have got empty row for TV and empty column for TV. So this can come in the starting or go at the end, right? By both logic. So let's just keep it at the start. And if we keep it at the start, our active block becomes this WXZ, TV at the right position. Is this point clear? I mean, if
Yes,
it,
sir. Yes, sir.
yeah. So now we have got WXZ. Let's try what values we get by matrix multiplication. Okay. Uh, yeah. This was our WXZ matrix. As we apply matrix multiplication, yeah, so what we are seeing is that uh, there is no non-zero diagonal, right?
yeah.
So what next? I mean, we wanted to find a loop. We can see the loop, right?
Yes.
So, but the n square is not giving us any hint on how to proceed. So, what we do next is we n-cube it. I mean, multiply it again. Let's see what it gives. So, for this, it would be multiplying n square
With M.
by n. So now you can see that we have got some values, right?
Which
So
means there is a cycle involving three activities, right? That's what.
no.
Oh,
Sir, we discussed this last time that one can signify that it is in cycle, or not having one can also cannot give us
yeah.
any clear idea,
Yes, 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 yeah.
right, sir? So we have got one now. As you can see that at max you have to go till the number of elements you have in your active matrix under consideration. Right now we have three. So and we didn't get anything in n square, but in n cube we got non-zero diagonal value, right?
Yes.
So uh, coming back here, our cycle we can see that it is wxz. I think it is visible to everyone, right? I mean, W gives information to X, X gives information to Z, and Z gives information to W. I hope this is clear.
Yes, sir.
Sir, it is clear,
Yeah,
but in like this is a small example, but in the case the example is big, how to relate and how to know that only one relation is there or two or five are there. So
yeah,
I, in my view, this process is valid because we cannot rely on the diagonal values also,
yeah.
that it will surely give the relation or it will not give the relation. We are not sure for that also. So why these techniques are still being used?
Yeah. Sir, what this matrix multiplication gives you is the starting point. When you have got a lot happening and you don't even know from where to start looking for the loop. I mean, see, if you have to code for this, how you can code is that you you square the matrix and check for non-diagonal element to be non-zero. I mean diagonal element to be non-zero. As soon as your code runs and the first activity it finds having non-zero diagonal value, it will go to that activity and go to the column or row of that activity and start looking for the loop. So that way you get one loop and you start again by building the block out of that loop and taking care of other activities. And that is a ongoing process till you get a lower triangular matrix. So this kind of is what you can say a computational algorithm. Uh, is is this somehow is does this somehow clear or give you your answer?
Yes, sir, clear, sir. Uh, Little bit I got the answer, but little bit confusion is there. I think when we proceed, it will be clear with
Uh,
the further process.
Yeah, let's proceed. I'm sure, yeah, you will
Yes,
understand.
sir.
okay. So now W X Z as one. So you don't need to do anything right now. I mean you have got another. Uh, so now what happens to this matrix? I mean this was we clubbed TV. So now you can go on in this manner that TV is your one element. I mean one block. W X Z another. Similarly, uh, TV and WXZ. So is there any kind of relationship between them?
No, no.
I don't think they are giving any
No,
information.
exactly. Yeah.
Yeah. So now my question arises: what should be the order? I mean, we saw this question initially for you and we also, right?
Yes.
So what should be the order? Are you getting why is this a
No.
question?
When you say what should be the order, what are you referring, sir?
I mean TV and WXZ. You have got two blocks.
Correct. Okay.
Yeah. So what should be the order? Where should we place them? I mean, Can
So
we?
what are the option? We can either place TV at the front or later, right? That's all. Only
Yeah,
two.
that's it.
Okay. Uh,
So, okay, so for this, let's go back to our slides. I have actually prepared some simulation component for later. Okay, so this is how we were getting fully partitioned matrix, right? This is the same, right? TV in the middle and WXZ.
correct. Yeah.
So now if I, uh, what has this given, this whole exercise has given you? It has given you some kind of order in these activities, which initially were RSTUV, right? TUV,
Ah.
WX, YZ, and now you have got them in some kind of order. But how to read that order? That is also a problem now. I mean, if you have got the duration for all these activities, and if they are in this order, you are not just going to add them, right? That let's say it all the diagonal values and we'll get our duration. If this was the exercise, we wouldn't have gone for partitioning and all. So what you can see from here is that Y is your first activity, no doubt for this. R comes next. What about TV and WXZ? So you can say that TV is one block. So in terms of scheduling, we'll be finding the duration of block TV and adding it. What about WXZ? We know that WXZ doesn't follow TV, right? I mean, we can't write WXZ here. It doesn't make sense because it is not following TV. There is no precedence here. But
Correct.
you can do WXZ with TV. You can do them in parallel, right? Both the blocks.
Yeah, exactly. They have no interdependency.
Yeah. So after R, you can come to WXZ. And once both these blocks are clear, you can go to U and you can go to S. Right? This kind of relationship is between U and S also. So now you get an idea that when you have got, let's talk in terms of levels. Y, nothing to worry about it. R, yes, R is following Y, so we have got another level. Now TV and WXZ, they are in one level. For U and S, they are in another level independent to each other. So for this, what we do is we do the bending. I mean, we make the bands, alternative bands. Okay, so uh, is this part clear to everyone? I mean that if you have to calculate the duration, you have to calculate the duration for this. And as let's say there is finish here, you can see that either TU, I mean TV or WXZ, one of these will be on critical path. Similarly, either U or either S will be on critical path.
Correct. Correct.
Okay, so now the question arises how to calculate the duration of TV and WXZ, because rest of these durations are clearly given to us, right?
Yes.
What to do for these, and for these we talked about simulation. So I am providing you with some data here, rework probabilities. So what do
Sir, one
we?
question, sir.
Yeah,
Sorry to interrupt, sir.
no issues.
Uh, Sir, before that, we do the some process called lower triangular format.
Yeah.
It has to be done before or afterward.
Sir, see, in partitioning, what we have got in the fully partitioned matrix, we have got only 2 marks above the diagonal,
Yes, sir.
right? And if we were going for tiering, we would know that okay, uh, if you do tiering for these 2 marks, what we will be left with is a lower triangular matrix. I mean everything below the lower diagonal, below the diagonal,
Yes, sir.
right? So this having everything below the lower triangular, I mean in a let me repeat, having every relationship below the diagonal means that we have got a fully partitioned matrix and we can proceed with scheduling. So in this case, if you consider these as blocks, and once you find the duration of these blocks, there is nothing above the diagonal then.
So that when we find up the blocks, sir.
Yeah.
So after finding the blocks, the upper triangular marks are least concerned. We
No.
can conclude that.
No, we are actually very much concerned about every X marks. So just that finding the block helps us determining that okay, if we were asked about tiering, that where would you tier so that it becomes a fully partitioned matrix, we would have pinpointed towards that cross mark. And in this case, having a block, there is no cross marks other than the blocks, right? And blocks we already determined that we will be solving together.
Yes, sir.
Okay, so I think we missed one step while while doing the, I mean while performing Excel calculations. So what would have happened is that when you got this, and you would have been clubbing everything. Once you club TV and WXZ,
Yes, sir.
YR, TVS1, WXZ,
WX.
and US. Uh, Wait a minute, do I have proper metrics? Yeah. So we will try to see that lower triangular matrix. TV, WXZ, U, and S. Yeah, that is the limit for our matrix now. Now let's start putting the cross marks. Y gives information to R and W, right? R gives information to R gives V and Z. Please help me complete this at a faster pace. TV, it would be S and V. So V is again the same. And for V, you have got T and U. For W, X, Z, W, you have got U and X. X is again inside. For X, you have got S and Z. So S, Z is again inside. And for Z, we have got W inside already. For U, U is not providing any information, and S is not providing information. So as you can see that once we have got them in uh, blocks, when you identified the loops, this matrix become what we have been discussing, right?
Lower triangular matrix. Yes, sir.
So you can call this a fully partitioned matrix if you are considering TV and WXZ as one.
Yes, sir.
So at that point we stop, and then for further steps we uh, take them different. I mean we take them as a block. Hopefully, I mean this
Okay.
answers. I mean you can see the load diagonal. I mean lower triangular matrix, right?
Yes, sir. Sir,
Okay.
but what about the sequence of TV and WX?
Uh,
Then we have
yeah.
to discuss this afterwards only, now. When we will make the flow diagram, in that we have to see that they will be going on parallelly.
Yes. I mean bending them. We can we can see them later also, or from here also. Like when you have been partitioning, you can you can see that y is at one level. I mean, let me write the levels here. Okay, you can see that you have to perform uh, y first, then after y r will follow. What
Yes,
about
sir.
this? What about this block? I mean, you can say that you can perform TV first or WXZ first. It doesn't matter to us. So you can perform this independently, and they are not dependent on each other. So these two elements you can perform independently. That will be your level 3. Similarly for U and S, you can perform them independently, side by side. So that is your level 4. So how we usually demonstrate it, we have them in colorful bands. I mean alternating colors. Let me show you. I will again have to open the Excel file. Can you guys see my screen? Yeah, I think I dropped out because of network issue. Yeah, can you guys see my screen now? Guys, can you hear me?
Yes.
Yes,
Uh,
sir. Yes.
okay, so can you see the Excel sheet that where I have kept them in different bands? Like first you do high, then you do R, then you have got TV and WXZ in one band, then U and S in another band. So visually also you can see that U and S will happen independently at almost at the same time. And for Y and R they are in different bands, alternating bands, so they will follow each other. Uh, so does this clear the concept of banding? I mean making the bands. Okay.
Hello.
Yeah, yes sir.
Yes, sir. So bands will be done once only after finding out all the active blocks, then making the matrix. In that case, only we can make the bands.
Yes.
Am I right, sir?
Yeah.
Okay, sir. Okay, sir.
Actually, this is just you can say a visual tool for us. I mean, when we are doing it manually, that we should know that which are independent or what follows what. In that case, for a machine, this is of no use. Okay, so we saw the active block, we saw the lower triangular matrix, and we also determined that okay, this is the kind of a network for which we have to find the duration. Now the missing thing is we have to find the duration of two blocks, TV and WXZ. So some simulation data has been provided to you, rework probabilities. So what do we mean by rework probability?
Rework probability, we may say, uh, like in this case, if T is repeated, then chances of repeating V is 20%, 0.2.
Yeah, yeah, that's it. I mean, that's what we are discussing here. That for V giving information to T, no, I mean, yeah, T giving information to V, we will have a 20% chance of it repeating. I mean, we at least have to do it once, right? So if we have to find out the duration of block TV, Uh, okay, do you guys remember what was the duration? I mean, T was 7, right? T was 7 and V was 9. Let me go back and check once. Mm, no, not in. Yeah. T7, V9, W4, X 6, and Z also 6. Okay. Yeah. So when you had to calculate the block, the duration for this block, you had to do activity T once, then you have to do activity V once. Now what is happening? You see that there is a cycle, right? V giving information to T. Uh, Now there is a probability that this cycle might happen or might not happen, right? You have a choice to make, and it might happen or it might not happen. Do you agree on this point?
So please repeat once again.
Uh, okay. So we have done T, we have done V now. What next? Either we can move on from this block, but we might repeat. I mean, there is this cross mark. I mean, giving cyclicity to it, right?
Sir, if the probability is 1, so it will be a non-ending process.
Yeah. So, uh,
Some assumptions has to be made.
so let's suppose that okay. Let's talk generally. I mean, if there is some probability, that means here we have to make a choice, right? Repeat or not. I mean, so what are we repeating? We are repeating T here, right? I mean, once you decide yes, you will repeat T, and no, you will end it. If this was your flow chart, this is how it would have happened. You start, you perform T, you perform V. Now it is again cyclic as seen here. So you decide now, do you have to repeat or not by rework probability. If it's no, you go towards the end. If yes, you repeat. And after you again repeat T, you again have to make a choice. This one 0.2%, 0.2, like, do you want to repeat or not? If no, you go towards end. If yes, you repeat V. What next? After repeating V, you again are at this point. Should we repeat or not? Can you see the cyclic version? I mean, what is happening here? Is this clear? I mean, what is happening? Or should I repeat it? Guys, I will need your answer to move forward.
But it is okay, but it will be very much helpful if it can be explained in the form of bar, like it was done in the video. So for the probability one, in my view,
Yeah.
rest other
Uh,
rest other can also share their views.
okay. I mean, is following this flowchart. What about others? I mean, is this flowchart not that clear? We will see it in bar form also.
It is somewhat clear, sir. Not the issue. We are getting it, but the it's a human psychology. The
Yeah.
the pictorial view we catch much faster than the flow.
Yeah.
So due to that, I'm taking.
Okay. Okay.
Okay.
We'll do it in that form also. Uh, any question regarding to this flow chart? I am asking this because, as you would have seen in the lecture, that we do some kind of computer simulation, right? So in case of computer simulation, we will be making such flowchart only. So yeah, we'll come to this flowchart next. Okay, so bar form. Let's try it in bar form. Uh, so what is happening is that we perform activity T. After activity T, we perform activity V. Now what is going to happen? You say that there is a cyclic relationship. So once you perform V, you again have to perform T, right? But there is also some probability attached. Let's say,
We have to do only 20% of T.
no, no, it's not. It's not doing 20% of T. It's doing only 20% time. We will be doing T. We'll see to it.
Okay.
Yeah, and after doing T, we again have the choice, and again we do V. So what is happening is that,
Sir, after doing T, we have the choice to do V or we have to do the V.
yes, sir.
There is
So
there is a doubt.
yeah,
After doing T, which is so we have the choice to do the V again or we have to do the V.
okay. Talking generally, right now you have already performed these two activities, right? These two activities once, T and V. Now,
Yes, sir.
as it is cyclic, if you are building something, it is just transfer of information, and if information is somewhat misleading, or information is like that you need to rework again, you will go back.
Yes, sir.
So uh, here it might happen that this V, after completing V, the information you get is that you can proceed towards the end, or you might get information that you have to repeat T.
Yes, sir.
I mean, I'm not talking about the rework probability I have given the values. I'm talking about what can happen.
Okay, sir.
Yeah. So similarly, once you perform T again, you have already done V once. So to
Yes, sir.
repeat V, you again have a choice. Either you go towards end or you repeat V, depending on the rework probability. Similarly, once you do V again, let's suppose you did T, then you did V, then again you decided that you will do T, then again you decided you will do V. What next? Again you have a choice. Either go towards the end, depending on the information you get, or there is some probability, so you do T again.
So, sir, which the second time we are doing the T, sir,
Yeah,
it is all captured according to the rework probability in that one only, na?
yeah.
The point two denotes 20% of the time.
No, sir. So it denotes that if you were if you would do 10 iterations of this process, 20% of the time it would go on to repeat the next V, and 80% of the time it would move towards the end.
Okay.
I mean, we discussed the design of beam example, right?
Yes, sir.
So in that case, if your assumptions are good enough, then you don't need to rework, right? In one go only you will find your answer. But it
Yes, sir.
might happen that in by your experience you can say that in 10% of the cases we rework.
Okay.
So that way you can say that okay, 90% of the time my assumption will be good, so there won't be any cycle. But 10% of the time there can be a cycle, and there will be a cycle.
So 10% times it will be a cycle. So 10% of what?
Uh, okay, 10% of what? Uh, you are that was a design example, right? Design of beam. So let's say you have to design 20 beams. So
Okay.
in that you can say that in 18 designs, I don't need to rework. but 10% of the designs, two designs, you can say that you will need some rework.
Okay.
Are you getting an idea now?
Yes, a little bit. Yes, sir.
Okay.
So in this case, like the duration of T is 7,
Yeah.
so in the second term, when we are taking T,
Yeah.
the duration will be taken 20% of 7 only, no?
No, no, no. We will do it for the complete duration.
Okay, we will do it for the complete duration.
Yeah, because there is no such
Okay,
condition given here. Like it might
okay.
happen that in design you will say that if you are changing just some information, the design might the design will finish only in half the time because rest of the work is already done. But in this case, there is no such condition given, so we are assuming that we will be doing the whole activity again.
So what is the criteria that we will move to end or we will move to the cyclic activity?
Yeah, that
It is an
criteria.
assumption or
No,
it is
yeah,
something else?
yeah, that is the probability that has been given. Rework probability.
No, that is okay.
Yeah,
Rework probability is given, sir.
yeah,
Like first we have done T, again after T we are doing V.
yeah,
After doing V, we have two options. Either we are going to end if our everything is okay,
yeah.
or we are going to repeat if some assumptions we have made are wrong.
Yes, sir. So
Then we are
just
doing
yeah. So just
so.
at this point, we don't know what is happening, right? I mean, the assumption might be correct, might be wrong, or it might this even might not be in terms of assumption. So what we have here is that after when here you get the probability. You don't know what is going to happen, but you have got a choice here, probability. That what it is telling you is that every time you do V, you are suppose your assumptions won't be right, so you will again have to do T. One is the probability, and when you perform T again, I mean that is given now. V to T rework probability is 1. So is it now getting a little clearer?
Yes, sir. It is getting clear, sir.
Okay, so now you have got 1 here and 0 here. That every time you are doing V, you will move on to, you will repeat T again. But
Yes,
now,
sir.
you have a choice. When you have finished T, you can either move towards end or repeat V, and it is decided by this 0.2. So 20% of the time you will repeat V, and 80% of the time you will move towards the end. So in this case, if you have to calculate the duration, what would be the duration? Duration, it would be 7 for T, 9 for V. Again you can see that you have to perform T. So 7 again. What about now? So either you can move towards the end. So duration becomes how much? 23.
23.
Yeah, but what if you perform 80% of the time it would be 23? What about rest 20%? You would again move on, right?
Yes, sir.
So again, if you start moving on, you will again perform V. So V is 9,
Again, we have to do T.
and
7.
as you know that the rework is 1, you have
1.
to do. So again you will do 7. So what is the duration now? 39.
23 and 16. 39.
39. So what you can see that, let's suppose there are 100 times you are doing it. So 80% of the time you will get the duration equal to 23. Now for the rest 20%, again there is a chance that for this 20%, 80% of the time you will get duration 39, and for rest 20% you will be performing this again. Are you getting an idea?
Yes, sir.
So in this way it goes on. So I'll take you back to the flow chart. Can you see the flow chart happening now?
Yes, sir. It is clear. Yes,
V,
sir.
V. Now, do you want to repeat it or not? If no, go towards AND. If yes, repeat T. Now, after repeating T, you have got again a choice. No towards the end. Yes, again repeat V. After repeat V, you have again got a choice. Right? So, let's see this via computer simulation. I I hope everybody is excited for this because it took me some time to make the models. Uh, okay, so this kind of flowchart we discussed. I'm using AnyLogic software for this, and this is an example of, you can say, discrete event simulation. So we have got activity T and activity V once. Then we have got a decision V to T. Then from that decision, either we can pack up, I mean it's done, or we can repeat T. After repeating T, we again have a choice T to V. Then we repeat V. Then again have a choice.
Sir, sir,
Yeah.
sir, one question.
Yes. Yes.
Sir, after activity V,
Yes.
first activity V,
Yeah.
we are moving to the decision
Yeah.
that we have to go to end or we have to repeat activity T.
Yeah.
But according to this rework probability,
One.
that matrix, sir,
Yeah.
it is one. So we have to repeat activity T after V,
Yes, sir. Sir, the only
because
reason.
after that we cannot go to end, na?
Yeah. Sir, the only reason I am showing you
Okay,
this.
for the clear. Okay, sir.
Yeah.
Understood, sir.
For the
If
completeness.
if it is not one,
Yeah.
if it is less than one, so this will be okay, sir.
Yeah. And sir, also what we will do is we will try to change the values and see if our answer changes.
Okay, sir. Okay, sir.
Okay. So is this flowchart clear to everyone? I hope it is clear.
Yes, sir. Yes.
Uh, okay. So you saw how many times we go on distributing the remaining activities. Like for first 80, we got some value. For next 20, again we'll be dividing it to two parts, like 80% getting the
And
some value,
20%.
for 20% repeating again, right?
Yes, sir.
So let's see it in simulation software. Is my screen visible or should I enlarge? I mean, can you see all the things clearly?
Yeah, we can zoom it out, sir. No problem.
Okay, I will
We
zoom
have
it.
zoom out.
Yeah, I will zoom it out a little. Just. Yeah. So as you can see, this is the same. I just added time measure so that we can measure how much time it is taking for each iteration to perform. So I'm running the model now. Okay, I guess I will have to share that screen. Can you guys see the model running? No, no. I guess it is a blank screen, right?
It is
Earlier
blank,
it was
sir.
coming actually.
Okay. Let me share my entire screen. That would be a little. Okay. Uh, so this is our AnyLogic environment. This is the model that we created. For this, what I'm doing is I'm doing it 1000 times. Let's see what happens. I will speed it up a little. As you can see that the agents are flowing, and as soon as they reach the end, we get the time. And this shows you the average cycle time. So running as fast as possible. As you can see that after 100 iterations, you can see that the average cycle time is 18.28 seconds, 18.28 minutes. Now, wait a minute. Wait. Sorry. I mean, other simulation ran. Okay, yeah, activity TV.
Yes, now it's okay.
Yeah,
Because 18 minutes, because 7 and 9, 16 is already dead. So it must be greater than 20, I think so.
yeah. No, actually, it was of the WXZ. We have got two
Okay,
blocks
okay.
now.
Yes.
Okay. So after 1,000 iterations, you can see that the cycle time average is coming out at 27 minutes.
Okay.
Okay. You can see that most of the cases it is completing in 23. For some it is completing in 39, and again for some it is taking some more time. At around 70 minutes also you can see one or two iterations happening. Right? A
Hmm.
very little orange
Yes,
mark.
yes, sir.
So if I stop it and I do it again, speeding it up, you can see it is now 27.08, and the value has changed a little.
Reason, sir?
Reason. Okay. So when we were running this simulation and in class also, in lecture also, we were given an hint about random number generation, right?
Uh,
Uh,
I'm not aware about that, sir.
okay.
I'm not sorry. Not
Yeah.
not heard the lecture clearly.
Okay. Actually,
Sorry for that.
it was just mentioned in passing. So
Okay.
what is happening is that there is nothing called random here. When computers also perform some simulation, or let's say just tossing the coin in a computer 1,000 times or a million times. So what is happening is that it is attaching that thing to some series, and by that
Okay.
series value, it is determining is it going to be head or tail. So if you fix that series, I mean, here right now, if I fix it that the seed is fixed and I run the simulation, yeah, the cycle time is now 26.79. But as the as the randomness is same, the next time also I repeat it, it should come out same, 26.76.
So my question is
Yeah,
the the probability is same
yeah,
20%
yes,
and 100%.
yeah.
If the values are same and the number of cycles are same, so what is the reason behind the changing the value for that average time of the cycle?
Okay, Sam. Uh, Sir, you have a coin and you toss
Yes,
it
sir.
10 times.
Okay, sir.
Probability of coming heads and tails are same, right, for each.
Same. Yes, sir.
But for each iteration, you will get 10 different values, right? I mean, 10 different sequence of 10 heads or tails.
Yes, sir.
Why? I mean, the probability is same. You are performing the same task. You know that 50% of the time head will come, 50% of the time tail will come.
So the sequence can also be same, na, sir? we can calculate the number of sequences also by the permutation and combinations.
Yeah, and there can be a lot of permutation and combination here, right?
Yes, sir.
So similar thing happens here also. That
Sir, there permutation combination. Uh, yes, sir. Agree. There can be permutation combinations.
yeah.
Yes, sir.
So the same thing happens here. That from fixing the seed, or I mean removing the randomness, you are kind of fixing it. That okay, there will be five heads in this order. There will be five tails in this order.
No, sir. But with the help of permutation and combination, we can get the number of sequences
Yeah.
we can get by tossing the coin 10 times.
Yeah. Sir,
It is
but
fixed. We will get the fixed sequence.
okay.
Let it be 100 or let it be 1000, X, Y, Z, any numbers.
Yeah.
So in this case also, the permutation cycles are same, sir.
Okay. Sir, let
So,
me.
but the value is changing. So,
Okay, sir. Sir, let
Now,
me.
can I interrupt?
Yes, sir. Yes, sir.
Actually, suppose that example you took, like we are tossing the coin 10 times. So sometimes it will be 5 times head, 5 times tails. Sometimes it will be 8 times head, 2 times tails. Sometimes it will be 3 times this, 7 times.
Yeah. So, so do you get the idea now? Hello.
first time we will get tail. According to that, for the rest 9, we have to calculate the permutations and combinations. Accordingly, the number of sequences will be fixed. My point is the number of sequences will be fixed. We can calculate with the help of permutation and combination. It will be 1 lakh or 10 lakhs. Just for an example, just giving the number. So the sequences will be fixed in the tossing of coin. In the same way, we are running the simulation in the system. We have fixed number of cycles, 1000 cycles. We have fixed the duration of activities, T activity V. The probability of reworking is also fixed. If all the things are fixed, the value should also be fixed. Is there any reason to change the value from 27.3 to 26.79?
Uh, yes. So let's write it out.
It is taking 4 iterations. Sometimes it is taking 3 iterations. Means after V and T repetition, you have not stopped, na? It is going on
No.
continuously.
Yes,
So
sir.
when you are repeating it from
V and T iteration is not stopping, and we will assuming that we will continue up to 1000 cycles.
yes,
It is fixed,
cycles is
sir.
1000, but in one cycle it is stopping at the 23. One cycle it is stopping at 39. Another cycle it is going up till 70. Another cycle is going up till 55. So sometimes computer does what it is doing, like only taking up to 55, not going beyond that. And sometimes it is taking up to 70, and it is not stopping that there also. Due to this, the variation is coming because we
But
have given a probability 20%,
computer will take
80%.
our
So
input only, no, sir.
Yes, sir.
yeah,
Computer
but
will run
input is
according to
vary,
the
no?
input only.
Yes,
Okay, sir, we
definitely.
will
That's
discuss it separately, sir. Not the issue.
yeah.
Little bit of confusion is there. Other
Uh,
participants are
yeah.
also waiting for further. We can discuss it after, sir. Sure, sir.
Yes.
I will note it down, sir. We will discuss it.
Okay. Uh, so let me. So shall I come back to the presentation? Oh, sorry, the simulation part. The computer simulation. Just give me a moment. I guess I will have to share my entire screen only. Okay, so we can see that the cycle time here is 26.76. What is this showing us? I mean, now we have got the average duration for this block, right? Let's run it again. Or as there, mm, let me change some variable for you. We were doing it 1,000 times. Let's just see what happens if we do it only one time. One time we are getting a cycle time of 23. For another iteration, again 23. For third iteration, you are getting 39.
Sir, we can't hear, sir.
Uh, okay, yeah, my bad. Yeah, so in third iteration we are getting 39. In fourth 23 again. In fifth 39. So out of 5 you are getting 39 two times, and 23 only 3 times, right? Kind of giving you a 40% probability, but in rework we defined it as only 20%. So is computer making a mistake? It is not making a mistake, it's just trying to follow the path in our given probability, but as we increase the number, it will bring it closer to what we have given. Like if we keep it 100 and run it, it is giving you 27 value. This v to t was 100%, right? Whatever is coming in has to go towards t, right? I mean, we had a probability of 1 here, rework probability of 1. Guys, can you hear me?
Yes, sir.
Okay, so I will move on with this. I mean, cycle time of 27. Now, similarly, let's calculate the cycle time for WXZ. Similar chart has been drawn, similar flow. For WXZ, it is coming 18.53 after 1000 iterations. Okay, 27, and for WXZ block, instead of 18 point, okay, we will take 18.23. Yeah. So what becomes our duration now? We have got y, and where was that slide? We have got y, r, t, v, w, x, z, u, and s. Y R T V W X Z U and S. Now you have the duration of Y R TV as 27, WXZ as
80.
18.26, and U and S. So can you determine the the duration for the whole project?
Yes, sir.
I think you guys can do this on your own. Just addition and checking for the critical path remains now. So that way you will get the estimated project duration. So moving to the next topic.
Critical path will be the longest duration, if I'm not wrong.
Yeah, the definition would be the same that we discussed in first.
Yeah, okay, sir.
Yes, sir.
If we are not doing the forward pass and backward pass like that, so if we can calculate like there are two activities in parallel, the longest duration path we can take it as the critical path.
So the logic must follow. So yes, the longest duration, it will be a critical path.
Okay, sir.
Yes, sir. So coming to the next topic that was discussed was BDM Beeline diagramming method. So my question to you is, what is?
Sir,
Yes.
sir, one question, sir.
Yeah.
Sir, judge before BDM.
Yeah.
That's in exams we will get the points like stimulation also
No, just conceptual questions on simulations.
only now.
Yeah, and even if you are getting to solve it, then it might happen that you have been given the limiting number of iterations that you have. After 2 or 3 cycles, you have to stop, or after
Okay.
each cycle, the duration is reducing. You just need to know the concept.
Okay. So like it is our first exam. It's a request if one sample exam paper can be made. Sample, not
Uh,
same I'm saying.
yeah.
Like the amount of numerical and the theoretical questions and numerical questions and the type of that numerical is small or big.
Ani-
Afterwards, not
yeah,
now.
Anikesh sir, can you
You can.
shed some light on this?
And in the question paper.
Yeah, I mean, it is similar to assignments,
Yeah,
right?
it is very much similar to the assignments.
Okay, sir.
Uh,
Okay, sir.
Very much
Then it
similar.
is okay.
It will be like you can say like 70% numerical, 30% theoretical, that type of thing. And MCQ type only will be there, and multiple choice can be there. Like you will select multiple options, correct? That one may be there. MCQ or MSQ type questions.
Okay, sir.
Basically, means nothing has changed from assignment. Similar, you can follow and go to the exams.
Okay, sir.
Okay, thank you. So coming to this, what are beelines and why is this being discussed?
At different points in time, the jobs share information, right, to
Yeah.
others. And because it may be the parameter that is being sent out takes so much time to actually get generated, right? So something like that. For example, if if you look at the top one,
Yes, sir.
you have divided the entire activity into G1, G2, G3, G4 as four sub activity, right? Sort
Okay.
of four sub discrete activities. So the first activity produces some information at the end of the third unit. Let's assume days. At the end of the third day, it is able to produce a required parameter and passes it to the next activity, which requires it, right?
Yes.
That's the way I interpret it, actually.
Yeah. Actually, that's a correct interpretation. I mean, accurate interpretation in this case. So what is happening is that till now, what we were discussing in case of parallel activities was that either they have got starts together, or they have got finishes together, or they have got some other kind of relationships between two activities. But what if they have got activity? What if they have got relationships during their duration? I mean, not at the end, not at the start, but during. I mean, in case of design activities, you can say that if one person is doing some structural design and the another is doing MEP design. So they might need inputs from from each other, not at the end but during the design part itself. So in that case, how to do the scheduling? So this BDM helps us there. Now what we have got here is that G is one activity, H is another activity, and I is our third activity. The total duration is I guess 15, no 14. 14, 11 and 11. But they are not exchanging information only at the endpoints. We have got intermediate control points where some parameter exchange is happening. Right? So let's try to calculate the total duration. We'll be going in a similar manner, forward pass, backward pass, and let's say forward pass, backward pass. Then what did we do? We calculated some float, right? So float, and yeah, one more thing. From first lecture, there is one thing pending about visualizing the free float, right? Right, sir?
Yes.
So we will see to it. Okay. Free float and critical path, of course. Yeah. So starting with G, I mean, let's see if this can be the starting with G here 0. 3 is the duration here, no incoming arrows, so this becomes 3. Moving
Yes.
on, 3 plus 4 7.
Yeah.
Please let me know if I'm making a mistake or you're not following me. Now coming to this point, we have got another arrow coming, so moving downwards. 3, no lag, lead, anything given. Now in this case, either it can be 7 or 3 plus 5 8. Right, from arrow
Yes.
it is 7, here 8.
Yeah.
Again 8, 8 and 3 11.
11.
But here there is another arrow coming, so we'll check downstairs first. 8, 8 plus 2 10. So
10.
either this can be 10 or 11. So 11. Going to this point, it can be 11 or 7 plus 3 10. So it becomes 11. 11 plus 4 15. This point 10 plus 5 15. So this can be either 15 or 14. So we'll take 15, bigger value.
Yeah.
15 plus 4 19.
90.
So that is our forward pass complete. Going backwards now, this is our 19. 19 minus 4 15. Backward arrow, no. Okay, so we might have to consider this part also.
Yeah.
Yeah. So
Sir, one question, sir.
yes, yes,
Sir,
sir.
with respect to the question in the assignment, sir,
Yeah.
of BDM, actually there were three activities, X, Y, Z or P1, P2, like that.
Okay.
Diagram was there.
Yeah.
But the finish, the project finish was with the middle one. Okay, sir.
Okay.
And the time duration was coming at the node was 91.
Okay.
And the last one, which is the third one,
Yeah.
the completion end was coming like 98. So it is possible, or there was some mistake in my calculation, because
Okay, sir.
the
So we will see what.
No, let's finish this and maybe we can see. Yeah.
No,
Let's get the flow otherwise.
Yes, sir. So I will just I'll just tell you what happens is that once we have got these three activities, we can see that there is no specific project start or project finish here, right? So what we would have done is we would have assumed a project start here, giving the start to each activity, and some project finish here. This project finish, if it was design, then I would have written it that okay, submission of design, connecting it here.
Yes. Yeah. Correct.
So, uh, I I would have to revisit the question, but in question it should be like it shouldn't be connected only to the middle activity, but to all three activities. So either it is a printing mistake or I mean it might be a typographical error, but it is supposed to be like this in the questions you get.
Okay, sir. We will discuss again, sir,
Yeah.
afterwards, not the issue.
Okay, so in this case also you will see what is happening is that here H3 we don't know the finish late finish. So from project finish we can take it as 19. We saw the same case in PDM also. 19. So this arrow, yeah, this is 15 only, less less value, right? Or the larger value.
Yeah, no, less value. Correct. 15.
Okay, so this becomes 10.
That becomes 10. Yeah.
Yeah. Or
No,
from
but
here,
we have to compute from the other way also, no? From
yeah,
H3.
yes. So from other way, it would have been 16.
16.
16, again, the smaller value is 10.
And yeah, this is a smaller one.
Yeah. For this part, it would have been 8.
And if
Uh,
you come that way also, it's 8.
yeah. For this, it's 19. 19 minus 4, 15. Coming back to this point, now this value is not 16, right? I mean, we wrote 16 from this, but coming via this arrow, it shows that it should be 15.
It should be, sorry. Yeah, yeah. Missed it.
Yeah. So 15, coming to this point, back, two arrows coming back, either it can be 8 or it can be 15 minus 3, 12,
12.
right?
It should be 8.
8. And for this again, I mean, we haven't got any starting or ending, right?
No.
So it can be either 5 or the ending arrow 0. Sorry, either 3 or 0, right?
Yes, yes. 8 minus 5, 3 or 0. There are no other dependency. Correct.
But if you see, it is coming from this also, na? So 8 minus 5, we have got 3 here. It cannot be 0.
Mm.
So similarly, 15, so either it can be 8 or 15 minus 3, 12. So this
12,
is 8.
8.
It can be 4 or 3. So it is 3.
Yes, 3.
It is 0. Uh, this is our backward pass. Any confusion till now? I mean, this is what we have been doing.
No, sir. No, sir. Yeah.
Okay, just a moment. Yeah. Uh, just so that the slide is a little on less messy side. Yeah, so now we move on to float calculation. In this case, we have got total float, right? So total float formula is the same, or by looking at the directions, latest finish minus early start minus the duration.
Duration, yeah.
Yeah, so in this case it is 0.
Yeah.
For
G2
this
is
one,
1.
1,
G3 is 5.
5,
G4 is 4.
4,
H1 is 0.
H1 is 0,
H2
H2
is
is
4.
4,
H3 is 5.
5,
I1 is 0.
I1 is 0,
I2 is 0.
I2 is also 0, and
I3 is 0 as well.
I3 is 0. So we have done float calculation also. Now can we see the critical path here? You can
Yeah.
see
G1,
that from G1,
it comes to H1 start.
yeah, to
It traverses H1, comes down to I1, I2,
Come-
I3, and ends.
comes down to I1,
Traverses along I1, I2, I3, and ends.
I3, and it's finished, right?
Yes.
So we have seen the critical path also. Okay, so now coming to the visualization part of float that was missing. What can you see the values for G3? Okay, just a
Sorry,
moment.
question is not clear.
Yeah, just a moment. I will. Okay, for G3 we have got 7, 11, 8, and 15, right?
Yeah.
Yeah. So let's take it outside. G3. The duration was 3, 7, 11, 8, and 15. This was the condition. Yeah. So let's draw the timeline here. 7, 8, 9, 10, 11, 12, 13, 14, 15. So 7 to 15, I mean, early start is 7, late finish is 15. So you have got this much of a time to do what is essentially a 3-day task, right? I
Yes.
mean, can you see that from 7 to 15 you have got a time, but the duration you require is only of 3 days.
Hmm.
Now, if you just focus, its early finish is 11. So if you don't want to affect any succeeding activities, you have got this much duration, but still you need only 3 days.
Sir, the duration is 5 days.
Duration is 5?
Isn't it just?
No, 3. 5
Oh,
is the
sorry, three.
total flow.
Okay.
Yeah. So again, if you go that, okay, it is starting at the late, starting at 8 and finishing at 11. In this case, you will see that 7, 11, uh, 7 and 15. So you can see that there is a lot of total float. It is like 5 days,
Yeah,
right?
total float is 5. Yeah.
Yeah. And if you don't want to interfere with the succeeding activities, the free float here is what? I mean, 11 minus 7, 4 minus 3, 1 day, right?
Yeah.
And independent float, you can see it's 0. I mean, if the previous activities have already taken their floats, taken the buffer available to them, and we don't want it to pass on any ahead, so we have 0 independent float here. So can you see this on the timeline now?
Uh, can you explain that independent float? How do I see it?
Okay, so let's do one thing. We'll take any other activity that has independent float, because with such a big network we will definitely have some. What about H2?
Sir, we may conclude one thing, sir.
Yeah.
In BDM, the free float, the formula which we are, the logic which we are using
Yes.
for total float and free float
Yeah.
may be different from the CPM,
uh, I
because
mean,
in that, sir, in forward pass, there is no between interdependencies. End
sir,
to end dependency is there.
yes, sir, actually what is happening
So
in,
due to that, the definition will change there.
uh, sir, the
The
float.
the the point which we were discussing that day,
Yes, sir.
which we concluded, sir, that every time it will be zero. Then
No, sir. Sir, actually,
there, in that case,
what is happening is that uh, in that case, the formula that we are using to calculate now, there is a small a logical flaw in that formula. Let me show it to you by
But
some
yeah,
by some diagrams. Okay.
okay, yeah,
Yeah.
that'd be helpful. But I thought to calculate the free float, we need to look at the successor activity. No,
Yeah.
no.
Yeah.
Okay.
So we will see that part right now. We have got activity A, B, and C. Okay. Uh, so and our focus is on activity B. I am just putting some random. I am not giving them numerical values because they they tend to get more confusing. Uh, T U V W. So what would you say? What is the early start for activity B? You will see that it is the early start of activity, early finish of activity A, right?
Yeah, yeah,
So
it's
this
Q.
would be Q.
Q. Yeah,
What about early finish of activity B?
that is Q plus the duration of B.
Yeah, let it be D. So you can say that it is Q plus D,
Yeah.
right? But you can finish it till T, right? I mean, you have.
Uh,
I mean,
yes, I can say it is T. Correct. Correct.
I mean, if Q plus D is not equal is less than D is less than T, that means you have got some buffer here, right?
Exactly. Yes, and without affecting T, you still have a float, sort of.
Yeah. So that float is your free float.
Ah, okay.
So what was happening in our case was that the relationship for the next for the successor activity was just one. So in this case, moving it by forward pass, we were getting the same values,
Ah,
right?
correct.
Q plus D here also, Q plus D, and we were moving on with the same value here. But let's suppose we have got another activity, uh, let's say H here, which finishes at T, early finishes T. So in that case, early start of activity T would be C would be T, right?
Correct. Correct.
So that brings that early finish for B should be T, not Q plus D.
Yes.
So now I hope you get why we were not getting the free float there. We were not looking in the right manner.
Yeah. And this is, I think, this definitely makes it better to understand.
Yeah. So, sir, do we have this question? I mean, does this clear it?
Okay. Now can we go back to our question? Actually, maybe we'll just see this.
Okay, we'll see this.
Yeah, because then now we understand. Okay. So we were discussing which one? G3, right? Yeah.
So G3 we discussed, and in G3 we saw that the independent float was 0. Now let's take some activity which has some independent float. What about H3? 11, 15, 15, and 19, and duration is 3. So you can say that the total float in this case is
15 minus 11, 8 minus 3, 5.
5. I mean, let me write 19 minus 11 minus 3, 5. Uh, Free float would be 15 minus 11 minus 3, right?
Yeah.
So that would be 2.
2. So
What about
float,
independent float?
that is 1.
How?
Sorry, 3.
The free float will be 1, sir.
Just a minute. Yeah, free float will be 1. What about independent float?
That will be 5 minus 1, 4, or am I getting it?
Okay, I think we made some mistake while writing this. Is this value 15 only?
Uh,
Yeah, late start. Okay, 19 minus 3 from this side.
11 plus 3 is equal to 14.
No, not 14. Yeah, it is G
Yeah,
from G3. If you come, it
yeah,
is
yeah,
11 plus 3
from this
14.
point
Correct,
we are
correct.
from
Yeah,
this point we are getting 15. From this point 19 minus 3 we are getting 16. Yeah, okay, so we have got 15. So in this
Yeah,
case
15. So
also,
I2 it will come 15.
yeah, from no, from I2 it will come 10.
No, no, sir. The early finish for H3.
Yeah, early finish, na?
For H3, I'm telling.
Yeah, yeah, yeah. Early finish, no, early finish would be 14 or 13. Yeah, 14
That 11 plus 3 is 14, but from
from,
I2, one arrow is coming,
yeah,
which is having a early finish 15,
yeah,
yeah, so
10
we
plus
are
due
15.
getting
to which
15.
So
Yeah,
we are getting 15.
these calculations are correct, right?
yeah, yeah, yeah.
So how are we getting such a wide? I mean, if you calculate that the latest start is 15. Okay, there is no independent float here in this case also, right?
Sir, can you
Can
remind
you
us,
please
please,
write with the
how to
formula?
calculate the independent float? Sorry, we.
Yeah. Uh, mm, okay. So independent float is latest start. Sorry, early finish minus late start minus the duration. I mean that's what we did here, right?
Really finish minus.
I mean late start. Sorry. Uh, yeah, early finish minus late start minus the duration.
Right.
Yeah. Mm,
Correct. Okay.
So the
so
float can be negative, sir.
yeah, that's what I'm thinking. These calculations float shouldn't be negative. It can be zero, but it shouldn't be negative.
Yeah, it cannot be less than 0, no, sir.
Yeah, we haven't taken that into account now. So maybe there is some again missing something that we missed in CPM. Similar thing.
That maybe we will calculate again, sir. It's no
Yeah.
issue. We
Uh,
will try it again at home.
okay. So you got the graphical idea. I mean, you guys can visualize now, right? Independent float, free float, and
Yeah, yeah.
total float.
Yes. At least it's much better. Yeah.
Yep. Okay. So there was one part also discussed about other techniques. So some simple questions and these type of questions you must have seen in assignments also. So for PERT, answer the following questions. What is the full form of PERT? Program evaluation and review technique, right?
Yes, sir.
Yeah. Time estimates used in PERT
Optimistic time, pessimistic time, and most
and
likely time.
most likely. So yeah, this is one question from my side. What role do resources play in time estimates? I mean,
What
you are
role?
telling me that there is uh, T optimistic, there is T pessimistic, and there is T most
Yeah.
likely, right?
Yeah.
Yes,
Yeah.
sir. Yes, sir.
So let's suppose that you have to make a road, and from that you determine that optimistic is 1 month, most likely is 2 months, and pessimistic is 3 months. So
Okay.
how did you find this out? Do resources play any role?
A lot.
How?
Resources also, and the conditions and the problems, like we may take the rainy season or at site, or any festival at any festival time at which the incoming of labor will be less, due to which the work will be delayed. So the
Uh,
labor is also a resource.
okay. So, sir, you are saying that resources play a time in this. I mean, play a role in this time estimate, right?
Yes, sir. Resource will play a time estimate, like a particular work in a normal days, uh, I'm just talking about the construction work.
Yeah.
After the maximum number of manpower we will get, it is in at the time of rainy season, since the month of June. The reason behind that is that uh, from after Holi to June, there is a very shortfall of manpower. At that time, the resource will play the major role for the progress of the work, because uh, after Holi, when labor leave the sites, after Holi March, there is a wedding seasons in the rural areas, which is a major thing. And after wedding season, there no, after Holi there is a katai for dhan, the
Yeah.
cutting,
Yes, sir.
harvesting. So and after that they have the wedding seasons, and after wedding season, just rainy season come, and when they get free, they come to site for the work. So this is the time when we face the difficulties. Practical fee.
Uh,
According to that, we plan the work. According to that, like we take the we increase the duration of any activity at the site for the proper planning. We can plan it that we will do the particular work in 1 month, but if the manpower is not there, it will be the optimistic that we will complete in 1 month, but
okay.
we know that the manpower will not be there. There will be shortage of manpower, so that is the pessimistic, that manpower will not be there, the shortage of man. So that work we will complete in 3 months, and then there is a hope. We will we were planning that we will get 100 manpower, but we got 150 manpower, so we will complete the work in 2 months. So it
Uh,
will play the role.
yes, sir. Sir, you are saying that it plays the role. So, but I don't. I mean, I don't think so. I'll go into it after the next question. Which distribution curve is followed?
So activities follow beta. I
Yeah.
think the project follows normal typically,
Project
right?
follow normal duration. So beta distribution curve. So how is expected time calculated?
Average
T0 plus
T0
4
plus
times.
TP plus 4TM divided by 6.
Yeah.
Uh,
So, sir, from what you are telling me is that this can be the beta distribution curve, right? With T0, TP, and TM, right, sir? TM, and so we are getting TE somewhere here.
Yes, sir.
T0 plus TP plus 4 TM by 6. Sir, my question to you all is, did we consider resources while determining T optimistic, T pessimistic, and T most likely?
No, sir.
Yes,
No. I mean,
yes,
sir, we are not actually taking
yes,
those things into account.
sir. For the proper planning of the execution of work, the resource must be taken care of
Yes, sir.
for 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 getting the planning succeeded.
Okay, sir.
There are two ways to make the plans. One is on the paper and one is to execute. There is a difference.
Yes, sir.
So
Sir, I agree wholeheartedly to your answer that okay, if we calculate that, let's suppose for making this road we required 2,000 man days. Okay, so if we have got 100 labors, then we can do it in 20 days, and if we have got 50, we can do it in 40 days, right?
yes, sir.
Uh, so this can become our T optimistic, T pessimistic, and somewhere between. Let's say we are sure of getting 70 labors, so we can finish it in around 1 month. That's what you are telling me, right, sir?
Yes, sir.
Okay, sir. What is happening is that
Sir, I got
per
your point, sir.
yes, sir.
I got your point that we are making the average of all the time, optimistic,
no, no, no,
pessimistic, and
no, no.
and uh, and the most likely.
Yes, sir.
So we are considering all the things and we are making the average of that, and we are making the plan according to the estimated time.
Yes, sir.
So,
Am I
so,
right, sir?
so, so,
Uh,
sir.
yes,
So,
sir.
are you telling when we are estimating pessimistically or optimistically, already we take into account the availability of number of resources, etc. Is that the implication? Ah,
No, sir. Sir, nothing like
no.
that. I
Okay.
mean, what is happening is that while calculating this, we already fixed this, right? That for this road we will need 2000 mandis. And
Yeah.
then and only then we went towards number of resources, availability of resources. What if we don't even have this estimate as accurate?
Then there is no way, right? Then you can only look at all things which are other than that, right? Like a favorable climate or some other factors, right? Which
Yes,
is nothing to do with the resource, and say, oh, the environment is very conducive, I'm going to get all the required information from so and so, right? You
yeah,
can assume everything will happen on time, for which you have a dependency, and assume that will be optimistic. So this is barring the calculation of availability of resources, nothing to do with that.
yeah. As soon as, yes, sir, as soon
No, sir.
as you,
The assumptions, like the sir has said,
yeah,
like Swaminathan sir was saying now, it is for the optimistic one. All the assumptions are different for different time assumptions. Like for optimistic time, the assumption is different, that it is working in the ideal condition. For pessimistic, it is the worst case we are considering. There is no manpower. But if there is no manpower, how the work can be taken? Some time is taking, that there is some resources. So the point of Venugopal sir is that if we are considering the resources in all the time calculation, optimistic most likely, and the pessimistic, and we are averaging it, so the resources role should not be there in the estimate. Am I right, sir?
yes, sir.
Venugopal sir.
Yes, sir. Sir, I will tell you why. I mean, uh, I know that as soon as we start linking this to a construction example, it becomes quite a resource availability problem. Like, if you give me sufficient resources, I will do it very in optimistic estimate, right? But uh, this question arises from the history of PERT. So, do any of you guys know why PERT was introduced or why PERT was researched?
What my understanding was, it is used more in research work where you don't have a data for a similar type of projects already available, right? You are
Yes, sir.
doing it first time, so you have no idea. You don't have any historical data to fall back.
Yes, sir. So, I mean, okay, this is how it went, but okay, for which case or why PERT was developed? Any idea?
Was it
And
for NASA by any chance?
yeah, yeah, it was for NASA. So what is happening is that your resources are fixed. I mean, you already have a team of scientists working on one problem. Now they this is a novel problem, that's why they are working on it. The resource is fixed now. Now they are estimating that okay, if everything goes according to the plan, we get every value in one go. We do not have to iterate much. We don't have to make many prototypes. Just one prototype is good enough. So in that case, they are estimating one time, and they are saying that is T optimistic. Then from their previous experience, they are saying that okay, it can happen that we get our answer in two iterations or something like that. That they are giving that is the most likely time. And when nothing is going according to the plan, and after a long chain of iterations, we are getting some answer. So that is the pessimistic time they are quoting. So you see that the resource is same, and the number of resources still the same, but you are getting different TO, TP, and TM. So I hope I gave you the idea that why resources don't play any role in this part. Similarly, for construction
Okay,
also,
that is okay.
yeah, in
But in construction point of view, I
yeah,
think it will be the answer for this will be the average one.
sir, in construction point of view, we won't be talking in terms of PERT. Uh, only only when you go into design phase, you can talk in terms of PERT. that okay, I'll be getting design in these many days, and then another team will take these many days, or suppose client is not accepting it, and again now, or in construction, if you want, you can take the example of land acquisition. Like initially you are planning that okay, uh, I have to complete LA for 10 kilometers of the stretch. 90 kilometers already is already available. So initially you can have three estimates for that, right? You are assuming from your previous experience that for 10 kilometers it will at least take you 4 months to convince each and every stakeholder. But if government has already taught them, or their need of money, or they also want the same project, so they can be convinced in 1 month or so. Be optimistic. And you know that there can be much conflicts also. There is the political party is not the same, or uh, some other uh, mm, some other factor comes into play, and it can take you more than 2 years. So in construction also you can see that with the same team, you have got T optimistic, T pessimistic, and T most likely. Yes, when we talk about some things like road construction, which we have been doing since ages now, I mean, for 3000 at least, Roman roads, 3000 years. So we know how many man days it will take. So we can consider resources.
Just a small joke, sir.
Yes, sir.
Can we make a PERT network for the Ayodhya temple? It is a uniqueness in on its own.
Sir, I mean, I
Activities
don't.
are similar.
So this is kind of a, what you can say. You are forcing me into such a politically tense situation. But see, you don't need to make a PERT for this.
No, no, sir,
Our home
just a
minister.
joke, sir. Just a
No,
joke.
so that's what I'm telling you. Our home minister already told that when Ayodhya temple will be inaugurated. So we already know the project deadline. It happens or not, how the engineers do it.
Yes, sir. Yes, sir.
It will happen on that day.
They have to do, sir, due to the political pressure.
Yeah, I mean, I won't say pressure. I will say motivation.
Yeah, yes, sir. That is
Yes,
the right word.
yes,
Sorry for the wrong word.
yeah. So yeah, you can make PERT for that, but in this case, you already have a project end. So this kind of brings to the con- end of week 4 contents. Anything you would like to discuss?
Sir, I want to ask one thing.
Yeah.
Will week 5 and week 6 will continue, or like we were having week 4 lectures only, so this will also be week 4 only?
So this will be week 4 only. So this is, yeah,
Okay, so
this is the last session for this.
this is the last live session.
Yeah. So
Oh,
we can extend it. I mean, yeah, for the questions you have.
Um, so, Venugopal sir, I really want to express my sincere thanks. This is one course where we have seen all a live session throughout every week, and it was a joyous discussion actually. Yeah,
Yes, sir.
thank you.
Thank you, sir. So, would you guys be willing to fill a feedback form for me? I mean, so that I can uh, take this into consideration and
It is
improve.
absolutely it is. It is our
sure, sir,
dharma.
sure, not the issue.
Not at all.
We would
Please.
like to fill that, sir.
Yeah.
So the link will be shared for the same, sir,
So I'm sharing you right now in the chat.
Okay.
in the chat box.
Yeah. Yes, sir. So Kuldeep, sir, you have raised your hand. Mm. Uh, Kuldeep, sir, if you can hear me, you can just turn on your mic and say.
Hello.
Yes, sir.
Good evening. Good evening.
Great.
Actually, for the last session, that fourth week, there was assignment. there was but some confusion regarding that network diagram. That some solution was there. One question was there.
In
Can
assignment 3 or assignment
yeah,
4?
assignment 4.
Uh,
That PERT diagram was there. No?
okay. Sir, actually, I
There
will.
was B successor actually. That was bit confusing actually. It was crossing the arrows.
Okay. So, sir, can this happen that can the arrows cross in case of activity on node network?
No,
Why
there
not?
can there may be a dummy activity I think, but
Sir, I'm
this
talking. I'm talking about activity on node network. In node, we don't have dummy activities, right?
yeah. There
So,
was one activity was crossing actually with that. I was a bit confused. That's why.
uh, okay, sir, just give me a moment to open the assignment. Okay, sir, in this case, I mean, you have to draw the network yourself. I mean, you have been given the table only, right?
Yes, yes.
Yeah. So,
If you
uh,
can draw it, actually, getting confused in that.
uh, so in this case, it would be better to go via activity on arrow network only and add dummies.
That was dummy only, na? I think in parts it is feasible to use dummies or what?
Yes, sir. Sir, see, both are activity on node and activity on arrow. They are just two types of representations. So, whatever you are comfortable with, you can go on with that. Now, the question comes for dummy, like we assumed in CPM that its duration is to be zero.
Zero.
Similarly, similarly in PERT, if you need three times for it, you can keep all three as zero.
If we can sort out that diagram, that will be more clear actually.
Uh, so I
If
can
time permits.
Yeah, so I can only, I can only clear the conceptual part related to the assignment problems,
Okay.
the current ones. This is a limitation from my side. I apologize for that.
Okay. No issue.
So you should, if there is some trouble in network, do post it on the discussion forum. We'll see to it.
Okay.
And sir, Swami sir, I saw your uh, message regarding that last problem, but
Yes. Yeah.
the but the week was so hectic that I couldn't address it.
No, no issues. Take your time.
Yes, I'll see to it.
Sir, if the numbers can be shared, so if we can have some query, it can be confirmed. If possible, if it allows your
Yeah,
permission.
actually, it's. I can definitely share, but you can directly message on discussion forum, no?
I think that is the right approach, Sunil.
Yeah, because most of our doubts would be now kind of a detailed type, requiring a detailed solution, right?
Exactly, sir. I totally agree, and I appreciate for the discussion forum which has been created with the course. But there are some problems or some doubts like which we which need discussions. Live discussions make the things more understandable. In my view,
Yeah,
everyone is, yeah, because we we have done the engineering with the all the time discussions only and grown up with the with discussions only.
yes,
So
sir.
we get things more clear with discussions rather than reading it.
Yeah, that's true. But
Not the
you
issue that uh, if it if the system does not allow you, it's not the issue.
Yeah. So you can mail me anytime regarding this.
Okay, sir, not the issue.
Yeah. So anything else you would like to know about the course or about any topic that was left untouched?
Nothing else. Thank you.
Okay, thank you. I would really appreciate if you guys can take a couple of minutes and fill the feedback form. It would help me a lot.
We will do it right away. Yeah, I'll do it. Yeah.
Okay.
Thanks anyway. Yeah.
Yeah.
Wish you wish you a nice weekend, all of you. Thank you.
Thank you. Thank you, everyone. Uh, so this is the last session. If there is any query, I would see to it on the discussion forum, or you can mail me also. Thank you for joining.
Thanks a lot, sir. Anikesh sir and Venugopal sir, thanks a lot for the great learning. I think from the lectures I have learned, but my doubts are cleared from the live sessions only, which I have written in my feedback also. These type of live sessions would be continued, which would be beneficial for participants also.
Yes, sir. Thank you,
Thank you,
sir.
sir. Thank you.
Thank you. Okay, I'll be ending the session now. Thank you.